Okay girls, the next topic that we're going to be looking at is the angles formed when we have parallel lines which are crossed by another line, which we call a transversal. You remember that parallel lines are two lines in the same plane, but they remain a constant distance apart, so that means they'd never meet. Remember also girls that we show parallel lines by putting an arrowhead on the line to indicate that those two lines are parallel. Now a transversal, girls, is just a line that crosses the parallel lines, and it's shown here in the red. I'm going to do a review of the angles that we've already covered in Year 7. We did supplementary angles, girls, and these are angles on a straight line and they add up to 180 degrees. So here angle B plus angle A equals 180 degrees. They're on a straight line here. So we can write that as angle B plus angle A equals 180 degrees. Then we have complementary angles, and complementary angles add up to 90 degrees. So we look at the diagram below. Angle A plus angle B adds up to 90 degrees. They're called complementary, and we can write that as angle A plus angle B equals 90 degrees. Then we had vertically opposite ones, girls. These are non-adjacent angles formed from the intersection of two lines, and they're equal in size. So let's look at this diagram below. We've got two pairs, A and B. They're not touching, they're not adjacent, not next to each other, they're opposite each other. And C and D. So we can say that angle A is vertically opposite to angle B, so therefore it's the same size as angle B. And angle C is vertically opposite angle D, and so that makes them the same size also, girls. So let's go on to review triangles from last year, and you'll remember that we had equilateral triangles, and they have all sides the same length and all angles are 60 degrees. So let's look at the diagram below. Angle A, B and C would be 60 degrees, and the three sides are marked equal. Then we had isosceles triangles. We have two sides the same length and two angles are the same. Let's have a look. These two sides here are marked the same, and angle A and B are equal in size. Then we had scalene triangles, where all the angles are a different size and all the sides are a different length. So angle A isn't the same as angle B or angle C, and all these sides are a different length here. And we remember again that the interior angles of any triangle add up to 180 degrees.